This is Hani. She runs a grocery store, which is her family business.
Honey,
Yes?
there are students who contact me to know how we operate our business. They want to know about the waiting line characteristic, arrival characteristic, and service facility characteristic.
Okay, let's go over there to discuss about this.
Okay.
Okay, so for the length of the line is unlimited. This means that customer can keep arriving and waiting as long as the shop is open. So next is about queue discipline. We use FIFO, first in and first out. So basically, the first customer that came into the line is the first to be served. So everyone gets served in order. No cutting lines. So this makes the service is more organized.
This grocery store uses a multi-channel system with 2 checkout counters, so more than one customer can be served at the same time. The checkout process is single-phase, where customer only need to pay at the counter.
For arrival characteristic, the size of a calling population is essentially infinite, which means there are no fixed limit to the number of customers who may visit the store at any given of time. The pattern of arrival at the system is random. Customers arrive independently and their occurrence cannot be predicted. The behavior of arrival exists is patient customer. Customer patiently wait in the queue until they are being served by the cashier.
The next day.
Are you guys okay? You guys seem too tired.
Today is very busy. The queue is too long.
Should I consider to add another counter? What do you guys think?
Have you done all the calculation about the total cost, about all the risks, and anything?
In that case, let's have a meeting this weekend. Hello everyone. So firstly, I want to give you guys salary. This is yours and this is yours.
Thank you,
So the reason I do this meeting is to hear about your opinion about should I consider to open another counter. So what you guys think?
By this, we need to prove whether 3 checkout counter is better than 2 checkout counters. So I need to know your arrival rate and service rate.
The arrival rate is 18 customer per hour and the service rate is 12 customer per hour.
But I need to consider about total cost too. So what?
From this situation, I think you need to use the green model to solve this problem.
How?
Like this.
This problem looks at a small grocery store that currently has 2 checkout counters. Customers arrive randomly and there is a cost involved when customers spend time waiting. Each checkout counter also has an operating cost. The owner is considering adding a 3rd checkout counter to improve service quality. So, the main goal of this problem is to compare the system with 2 counters and 3 counters in terms of total cost. Based on the results, we then advise the owner on the most suitable number of checkout counters.
We use the MMS Queen model because the grocery store has 2 checkout, which means there is more than 1 server serving shoppers. In this case, there is 2 checkout and the arrival rate is 18 customer per hour. And the service rate is 3 shoppers every 15 minutes equals to 12 customer per hour. Next, the cost waiting is 2 ringgit per hour. And lastly, the cost survey is 7 ringgit per hour. To begin our calculation, we need to use this formula to find total cost. And in total cost, we need to find LQ. LQ, which is average number customer in the queue. And we need to find 4 first using this formula. We substitute into the formula and we will get 0.75.
Next, we need to find the P naught, which is the probability that there is no customer in the system. We use the standard MM2 formula for P naught. After substituting and simplify the equation, we can say that the P naught is 1/7 or 0.1429. This means that there is 14.29% chance that the system has no customer. Next, we need to find the LQ, which is the average number of customer waiting in queue. We use LQ formula for MM2 system, and as you can see, the LQ is equals to 27/14 or 1.9286. This means, on average, there is 1.93 customer are waiting in line. Finally, we can get the total cost. So, the total cost is RM 70 ringgit and 86 cents.
After looking system with 2 counters, now we calculate for 3 counters. These are the information given for this case, and now we assume the grocery stores operates 3 counters. Using the given values, we substitute them into relevant formulas. We apply the same total cost formula as the previous case, but now with 3 servers. From the calculation, the utilization factor is 0.5, meaning the counters are busy about 50% of the time. With 3 counters, the utilization value is lower compared to 2 counters.
Then we find P0 by substitute the obtained value into the formula, and we get 4/19 or 0.2105. Next, we will find the average number of customer waiting by substitute all the needed value into the formula. Then we get 9/38 equal to 0.2368 equal to 1 customer. Then we find total cost by substitute all the value to. Then we get RM 21.47. Total cost of operating 2 counter is lower than operating 3 counter. Therefore, we decide to stay with operating 2 checkout counters. For the conclusion, by using the MMS QA model, the analysis showed that hiring 2 checkout counter is the best option for the grocery store. Therefore, the 2 checkout counter is adequate since the system is stable and operates at the minimum total cost.
Queuing theory states that the goal of a waiting line system is to balance shoppers' waiting time and service costs in order to minimize the total operating costs. In this case, shoppers wait for about 6 to 7 minutes, which is considered reasonable for a grocery store, and that's make a happy shoppers. This indicates the current number of checkout, which is 2 checkouts, is acceptable.
Although adding a 3rd checkout counter reduces customer waiting time, the additional service cost is higher than the saving from reduced waiting time.
Therefore, the total cost is lower when only 2 checkout counters are used. In conclusion, the owner is advised to maintain 2 checkout counters as it provides an efficient level of service at the minimum total cost.
So, that's all from us.